Hi friends, welcome to our channel. In this video, we are going to look at problem 1233. Remove subfolders from the file system. This is today's daily challenge problem. So in our explanation here, there are two important ingredients. One is the idea of trial, and the other is backtracking. So backtracking is used to find all rootToLeafPaths. So I'm not going to read through the problem statement, but one comment, that is, if a subfolder actually, and the original folder, it has a relation of substring relation, right? So for example, this is one folder, and this one is a subfolder, and then the former one is a substring of this subfolder, right? So this is also the observation that enables us to use trial idea, right? So here you need to read through the constraints about the problem size and the further assumptions. So now, to save time, so I'm going to directly move to the coding, and in between we are going to explain the main idea. First, I'm going to sort this folder. So the order to insert things or strings into the trial is very important. So that's why we first sort this, and then I'm going to use a trie. So initialize it. So I'm just going to use nested dictionary to represent the trial, because this problem is very straightforward or very easy. So then I'm going to define a insert function. So here the insert function should take into the logic of the problem. So I'm going to split each of the given string using the slash, right? So then it's going to have like A and B and C, right? Array. So I'm going to insert this array into the trial. So first, let's get the length of this array, right? So then I'm going to set the current to be the current trie status, right? And then I'm going to do insertion. So for I item in enumerate array. So here we are going to use enumerate to track the index. The reason is that at the end we need to mark that it's a full path, or the end, right? So first, if item not in the trie, not as a key, right? So we are going to set current item equals another trie, or just an empty dictionary, and then we update the current to be the current item. So this one. Another thing to notice that if I equals n-1, that is, this is the end. So we are going to add a mark, meaning that this is the end of a folder. This is the one thing. Another one is that if item not in trie, so where is in trie, so we are going to update here to be the current item. Then if star is a key in current, it means that we have already have some prefix include being of this array. So in this case, this path corresponding to this array must be a sub corresponding to a subfolder. So we don't need to consider it. So we break. So also, if n equal I equals n-1, indicating end, so we need to put this one. Let's make it true. So this will be the utility function for insertion, and for this problem, this utility will be sufficient. So now let's modify the trial data. So we are going to for path in folder. So first, I'm going to get the path list, right? So we just do path split using this at this one, right? And then we will have something like you can do a print path list. You see what you are going to get, right? You're going to get some empty thing. So we need to pop out this one. So what we can do is pop. So here I pop 0, but pop 0 takes some more time. But you can make this one a deck and then pop from left. But for this problem, let's just use this. So once we get this, so we do insert we insert this path list to the trie. So then you can print out the trie status. So notice that for the first example, we should have 3. So from one is A, right? And another is C to D, right? And C, D, E, and so this is the case 1. Yeah, C, D, E, and this is the F, C, F, right? So now let me see if I missed something. So if item not in current, so current up to here, and then set current to be this one, right? Then we set this. Otherwise, so we break, and then if this, so we split here, and then we get this one. Let me check this information again. So this is the first one. So the first one should get A and C, C, D, and CF. But here we have a E, right? So C, I see. Let's see if I make the sort trie, and then if item not in, we're going to do this. If so here the 2 if current in, so we're going to break. So this is right. Let's say A and C, D, but this will give you C, D, E. It's not right. So let me see. Insert n equals array, current equals trie, and so here is current. So now if you update this one, so you should get A and CD and CF. This is for the first example. So for the second example, you are going to get A, and for the third one, you are going to get A, B, C, and A, C, A, right? A, C, A, B, C, A, B, C, A, and A, B, and D, right? All right. So now we know this is contains the information we're going to return. So the question here is how to get those information. So now let me write a function to extract all those information. So what I'm going to do is to write a utility function to get all rootToLeafPaths. So for this purpose, I'm going to use backtracking. So this actually, if you can think of this as a binary tree, right? So in the binary tree case, how do you get all the rootToLeafPaths? So you can write a very simple backtracking function. So now here it's similar, but for each key it might have multiple children. So now let's write this one. So let's call it collect path. So here I have a current, we have path. So this path is used to construct the specific path, and then we are going to add to this path the result. So first, if current equals this one, equals this dictionary, just this mark, right? So this is our stop condition, so we're going to return. Otherwise, so for key for value in current items, so what we are going to do, so first we add the current key into the path, and then let's check if value is also this one. So we are going to append the current path to the full path of the result. So here I'm going to append this thing. I'm going to use a John. So for this in the path, and otherwise, what we do? So we collect the path. So from this current one, so this is the next level of current, right? And then we have path. The state actually changed. So another path. So this is for this root. So after we try this, we need to go back and try others. So here we do path pop. So if you see the pattern, so here we append the key. Here we pass this key. So this forms this indication of backtracking. So now with this function, let's initialize path and initially empty and pass. So this is the result we are going to need. And then let's call this function collect path, right? So the current will be our trie, and the path will be this one, and the plural form. So after you call this function, let's print out this path, right? So what do you get? Let's see. So here collection path is not defined. Let me see. Collect path. Collect. So here's a plural form. So you are going to get this thing, right? A, C, D, C, F. It's almost there, but missing a starting a slash. So we can add that slash. So what we do is this. So let's return. So the slash plus the item for item in path if item is not empty, right? So now let's run it to check. So let's see. What do we do? So we return this one. So output. So y is 0. Let me see. Collect path. So here actually this plural form. Yeah, it matches all the three cases, right? So actually once you know the overall idea, so you can manipulate how you write the function to get all the rootToLeafPaths along this idea. So now let me submit for the generic case. Yeah, it passes all the cases. So with that said, I guess we finished the coding part. Now let me give you a quick summary. So in this video, we do this problem using two ingredients. One is the idea of trial data structure. Another one is a backtracking technique to find all rootToLeafPaths. With that said, that's it for the current video. Thank you for watching.